All right, there's 4 things that we're going to go over this lesson, right? The main ideas are here. We're going to talk about dividing polynomials. Then I'm going to talk to you about how to do synthetic division. And that's probably as far as we'll get today. And then you guys have to do the factor theorem and the remainder theorem on your own. They're not too bad. They're very gentle theorems. So those are the 4 main concepts that we're going to do today, all right? It's gentle. Very gentle. Okay, who remembers how to do this? The number 237 divided by 4. We're doing long division. Who remembers how to do it? Okay, hold on. Okay, good. So 5 here, right? 5 times 4, of course, is 20. So what I want us to pay attention to here is the structure as to what we're doing. And then we subtract, right? 23 take away 20 is 3. Bring down the 7, of course. 4 goes into 37 9 times. Because 9 times 4 is 36. We have 1 left over. Okay, so who remembers what all these things are called? What do you call this number underneath here? The dividend. Very good. Okay, that's called the dividend. What do you call this number out here? The divisor. Very good. Okay, what do you call this thing up here? Quotient. Very good. That's the quotient. And then, of course, what do you call this thing down here? Your remainder. All right. So these are the 4 parts of when we're doing long division. The reason I'm showing these to you is because these same 4 parts work exactly as they do in polynomials as they do for real numbers, right? And I'm not sure how many of you are actually aware of this, but there is a relationship between these 4 parts, right? So the dividend is actually equal to, anybody remember this? The divisor multiplied by the quotient, very good. And then added to what? The remainder. Did you guys know that? You didn't know that, right? It's amazing, like you how much we forget, right? So check this out, the dividend, so in our case, I'll prove it to you right now. In our case, the dividend was 237, right? So 237 I'm claiming is the same thing as the divisor, which is 4, multiplied by the quotient, which is 59, and then added to 1.
Makes sense.
Well, yeah, right?
Doing the complete opposite thing you just did.
There you go. 236, right? And then plus 1. Of course, we get 237. Yes. Yeah, so I want to point out to you that this right here is going to also work for polynomials. If it works for our numbers in here, it's going to work for polynomials as well. So when you are working with polynomials, this relationship still holds true. Okay? Okay, so we have long division on polynomials. Works. Yeah, this is if you had Miss May, it's the slam and stack 'em, bam 'em thing or whatever. Okay? So I don't really know what it means, so I'm going to show you how I know how to do it. Okay? Slam the ball. There you go. So here's how this works, right? You look at the outside number here, and you have this polynomial. So our dividend is x squared plus 10x plus 2. Our divisor is x plus 3. So we look at the biggest exponent here is 1, right? And the biggest exponent here is 2. So we ask ourselves, how many times does x go into x squared? Of course, the answer is x. The reason is because x times x gives you x squared. All right? And then we multiply x times 3, and we get a positive 3x. So notice what I'm doing. I want you to realize that. Notice that all of my x squares are lining up, all of my x terms are lining up, and all of my constant terms are going to line up too. So I want you to imagine these columns that you're keeping all the way down the line. Okay, I'll erase those for now. But I want you to imagine those columns up. Now, what did we do up above? Well, we put parentheses around this, and I'm going to make you put parentheses around it because otherwise you're going to forget to distribute that minus sign if you don't. So with parentheses around it, we ask ourselves x squared minus x squared. You should always get 0 here. That's by design. It's designed to be 0 there because you're factoring out the x from the x squared. Okay, then if I take 10x and subtract 3x, I would get a positive 7x, and I would bring down the positive 2. Now, how do you know if you can keep going or not?
X could go into...
Yeah, you're looking here, right? This exponent and this exponent, they're the same. As soon as the divisor becomes bigger than what you're trying to divide into, you can no longer move. So, but because they're equal, you can still move. So how many times does x squared go into 7x? Yeah, it'd be a positive 7, right? So positive 7. So I got 7 times x gives me the 7x. 7 times 3 gives me a positive 21. And of course, I subtract, and notice I'm getting a 0 by design, right? And then 2 minus 21 is that, what's that, negative 19? So therefore, my remainder is negative 19. So this part is my quotient, and my remainder is negative 19. The book might write the answer as an x plus 7 plus a negative 19 divided by an x plus 3. That's okay too. Either way is fine with me. But if I just ask you for the quotient and the remainder, then this is all you have to give it. So I give it to you in a different form, all right? Which one of these two polynomials is going to be the dividend? The big one on the top. Yes, that means the smaller one is going to be the divisor, right? So what do you notice about the dividend here? I have a fourth power, I have a third power, I have no squared power, I have a first, and then I have a 0, right? Yeah, so we need a placeholder, okay? So I brought that to your attention for that. So we're going to do this. 6x to the fourth plus 5x squared. Oops, sorry, 5x to the third, I mean. Plus a 0x squared plus 3x and then a minus 5. And we're going to divide this by 3x squared minus 2. I'm going to move this whole thing up so everybody can see. Alright, let's see here. How many times does 3x squared go into 6x to the fourth? 2x squared times, because 2x squared times, so 2 times 3, that's your 6, right? X squared times x squared is x to the fourth. Good. 2x squared times the negative 2x? Minus 4x cubed, right? So again, we're going to draw our line, we're going to subtract. You should get 0 by design, okay? Now I got 5x to the fourth minus a minus, so that's a plus, right? So that's going to give me what? A positive 9x to the third. And then bring down the plus 0x squared. So far so good? Okay, how many times 3x squared go into 9x cubed? A 3x times, very good. So that's going to give me a 9x to the third. 3x times the negative 2 is a negative 6x squared.
Wait, why
So I'm going to have nothing here. So 0 take away a negative 6x squared, what's that become? A positive 6x squared, good. Bring down the plus 3x. Can I keep going? Yeah, I sure can, right? Because I have a squared here, and I have a squared down here, right? So I can keep going. So 3x squared into 6x squared is what? 2, there you go. So 6x squared, and then 2 times the negative 2 would be a negative 4x. Alright. 0 by design. I'm subtracting here. So 3x plus, that'd be a positive 7x, right? And then bring down the minus 5, and you're done. So your quotient is 2x squared plus a 3x plus 2. Your remainder is a 7x minus 5. Okay, try this one on your own, and we'll discuss the answer in a second. So there's the answer here, so you can check later, see if you got it right. So I'm going to do this problem two ways. I'm going to do one on the left-hand side, what we've just been learning, and on the right-hand side, I'm going to use synthetic division, and I want to show you the parallels between the two. So I'll do this one in kind of a faster version, since we've already done it. So x goes into x cubed, this is x squared. So that's going to give me x cubed. It's going to be a minus 3x squared. I'm going to draw a line. I am going to subtract. I'm going to get nothing here. So 4x squared minus a positive, that'd be a 7x squared. Then I'm going to bring down my minus 5x. X goes into 7x squared, a positive 7x times. That would give me 7x squared, and this would give me minus 21x. And then I put parentheses, and I would subtract, and I get nothing, and then negative 5 plus 21, that gives me, what, 16x? And then I would bring down my positive 5. X goes into 16x, a positive 16 times. That would give me 16x. 16 times negative 3 is negative 48. Did that right? Yeah. And then I would subtract, and I get nothing by design, 5, so I get 53 would be my remainder. Okay? We just did that, and that's all good, right? So now I'm going to do the same problem for you, except I'm going to do it in synthetic division. So I'm going to put a number 3 over here, and I'm going to draw this little house that it lives in, okay? And I'm going to write down some numbers, and I want to see if you can figure out where these numbers are coming from. I'm going to write down the number 1, 4, negative 5, and 5. Some of you have seen this show before. Then the structure goes, I'm going to skip a line and draw a line. Skip a line, draw a line. And I'm going to bring down my 1, and everything gets added here. So here's what I do. Check this out. If I take 1 and multiply it by 3, 3 times 1 is what? 3. And if I add this up, what do I get?
7.
Okay, now look over here for just 1 second in my highlighter. Does anybody see a 4 and a 3 and a 7 stacked up anywhere? Oh, look at that. That's interesting, huh? That's cool. All right, let's keep going. All right. So 7 times 3 is 21, right? Add these up together, and what do you get? You get a 16. Anybody see a negative 5 and a positive 21 and a 16 lined up anywhere? Oh, look at this structure. Pretty cool, right? All right. So let's keep going with it. 16 times 3 is 48. If I add these together, what do I get? 53. Okay. And likewise, does anybody see a 5, a 48, and a 53 stacked up together? So you can kind of see what we've done. If we take that highlighted stack and you put it over, you can do something called synthetic division. So let's talk about what all these things are. Okay. Okay. No. So here's our remainder.
It's remainder constant. Oh, you don't. You're right.
Here's the remainder, okay? What does this part represent? Yeah, this represents the quotient. This represents your x squared plus your 7x plus your 16. So now the only tricky part is realizing that that number was 3, but this number was negative 3. And the reason is because we're checking to see if this is a factor of your dividend, right? Then 3 would be a 0, and that's getting us into the factor theorem. But before we jump ahead of ourselves here, everybody loves synthetic division, and for obvious reasons, it's a lot less work, and you just deal with the numbers versus carrying everything around. But it's very limited. You can only use it, you can only use it when you're dividing by a polynomial that is a binomial, something like that. So if you're dividing by a trinomial, it's not going to work for you. So you need to know how to do both, okay? So let's write down some observations that we've made. Okay, so some observations for synthetic division. S/D looks like a division sign. Huh. Bad joke. Okay, first thing, you should notice that it's only used when you're dividing by the form of x plus or minus some constant c. So you can only use it when you're dividing by some polynomial that is a binomial, so x plus or minus c. In the last example, you can see that this is of that form, x minus 3. So the c in this case would be 3. Does that make sense? Okay. The second observation that we have to make here is you take the opposite value for c. So in that last example, you'll notice that it was an x minus 3. In our synthetic division, we used positive 3, right? Okay, let's take a look at this example, and let's see if we can actually use synthetic division. Looks like we can, right? Because we're dividing by this that has the right structure of an x plus or minus c. So how we're going to set this up, here's what we're going to do. We're going to take negative 2. That's what we're going to check. Why am I taking negative 2 for this one? It's the opposite, right? Okay. And then I'm going to write down some numbers. I'm going to write down 5. Then I'm actually going to write down the number 0. I wonder if you can tell me why I'm writing the number 0. Very good. There's no x squared value, okay?
Why did we have to do that for the
Well, check. If you look at the last term, look, they were all there. 3, 2, 1, and then 0. That's why, Claire. Okay? So in this case, same thing happening, right? If we are missing a term in our dividend, we have to put a value in there, a placeholder. So here we go. Here, let the fun begin. 5 times negative 2, negative 10. Add these up, what do you get? Negative 10. Multiply them, what do you get? 20. Add them up, what do you get? 26. Multiply them, what do you get? Negative 50. 52. Thank you. Negative 52. Add them up, what do you get? Negative 44. So what is the quotient then?
5x squared minus 10x plus 26.
Very good. The quotient would be 5x squared minus 10x plus 26. What would the remainder be? Or the remainder of negative 44. If you want to write it like that, you're more than welcome to. You can just tell me what the quotient and the remainder are. Okay, box 8 is all about the factor theorem. The factor theorem essentially says something very, very simple. Okay, so if you're given some polynomial f of x, any polynomial, It says two things. It says if f of c, so some constant, if f of c is equal to 0, then you know that x minus c is going to be a factor. And it also says the reverse of that. Okay, if x minus c is a factor, then you're guaranteed that f of c is equal to 0. So this is what the factor theorem states, and let me show you how the factor theorem works in the next box. Okay, so here it is. It's asking, is x minus 3 a factor of this polynomial right here? 2x cubed minus 3x squared minus 11x plus 6, okay? Well, the cool thing about factor theorem is that we can use synthetic division to check to see. So I'm going to put a 3 out. I'm going to write down what I have. 2, negative 3, negative 11, and then a 6. Skip a line and draw a line. Bring down. Add this up. This is going to give me 2. This is going to give me 6. Add it up gives me 3. Adding that together, multiplying 3 and 3 gives me 9. This is going to give me a negative 2. This gives me negative 6. Oh, look at that. I have a 0. So because I have a 0 down here, right, here's what I know. I know that f of 3 is equal to 0. Well, that implies that x minus 3 is a factor. And that's exactly what the factor theorem is stating up here, right? Then f of c is 0 and x minus c is a factor. Let me give you another example. Okay, it's asking, is x plus 1 a factor of 15x cubed plus 14x squared of this polynomial here all the way down? So again, we're going to use synthetic division to check. So I'm going to take negative 1. So notice I'm taking the opposite value of c. I'm going to write down 15. I'm going to write down 14. I'm going to write down negative 3. I'm going to write down negative 2. Alright, so I'm going to bring down my 15 here and add this up. So 15 times negative 1 is negative 15. Add these up, I get negative 1. Negative 1 times negative 1 is positive 1. Add these up, I get a negative 2. Negative 2 times the negative 1 is a positive 2. That gives me a 0. So because I get a 0 here, I know that f of negative 1 equals 0. And that means that x plus 1 is a factor. So what you're looking for, you guys, is getting a 0 or getting no remainder when you do synthetic division to check to see if something is a factor. Okay, here's what the remainder theorem is saying. It's the last theorem of the day. Okay, it says if f of x is divided by x minus c, then the remainder is just the same thing as f of c. Okay, so let me give you an example of what that means. Okay, I'm going to take this polynomial here, x cubed minus 4x squared plus 5x plus 3. I'm going to divide it by an x minus 2. It has the right form, so I can use synthetic division. So I'm going to take 2, multiply it by 1, negative 4, 5, 3. Or not multiply, divide out, right? And then I'm going to do bring down. So I'm going to get 2 here. Add this together gives me negative 2. Multiply gives me negative 4. Adding gives me 1. Times 2 gives me 5 here. So we know right away that x minus 2, this is not really a factor because I don't get a 0 here, but this is illustrating a different point. Watch this. If I actually evaluate f of 2 into my function, right, here's what I would get. If I evaluate f of 2 right here for this function, if I took 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3, look what you get here. This is going to be 8. This is going to be a negative 16, and then 10 and 3 is going to be 13. If you add this together, check it out, you get 5. That's what this is saying right here. So it's if a polynomial is divided by x minus c, so I took this polynomial, divided it by an x minus c, using synthetic division, the remainder is the exact same thing as evaluating that function for that value, and that's what that's trying to show. Okay, here's a classic example as to what this is asking, okay? What will the remainder be when this polynomial, this on top, 2x cubed minus 11x squared plus 7x minus 5, is divided by this polynomial here, x minus 4? Well, the remainder theorem says the remainder will just be f of 4. Now notice I'm taking the opposite of that because I'm doing x minus c, right? So in this case, my c was a 4. So if I evaluate f of 4, I would get 2 times 4 cubed minus 11 times 4 squared plus 7 times 4 minus 5. When you do all of this, ladies and gentlemen, you get an answer of negative 25. Okay? So that's what the remainder will be, and here I will show it to you and prove it to you on this side. So if I took 4 and I plugged in, do synthetic division of 2, negative 11, 7, and a negative 5, I bring down my 2, add this together, right? So 2 that would give me an 8, this would give me a negative 3, multiplying would give me a negative 12, adding would give me negative 5, multiplying would give me negative 20, holy cow, negative 25, look, there it is. That's what the remainder theorem is saying. Alright, you guys, have a great weekend.